So I'm Nora Jones. For those of you that thought you were getting a concert today, I deeply apologize. Jokes aside, I'm a senior software engineer at Netflix specializing in chaos engineering. Prior to joining Netflix, I just joined 3 months ago, I had the opportunity to do chaos engineering at a few startups, one of them being Jet.com, which is an e-commerce company, and the other being Alarm.com, which is a security and home automation company. Most recently, I actually got to write a chaos engineering book with a few of my stunning colleagues at Netflix, and we have a few extra copies here today if you'd like to pick one up after the presentation. So first and foremost in this talk today, we're going to talk about what even is chaos engineering, because it means a lot of different things to a lot of different people. We're going to talk about how you need to choose your own adventure with chaos, and we'll actually go through some scenarios where we choose adventures together. We'll go through different phases of chaos that I recommend unleashing before unleashing, your full-blown chaos. We'll talk about the road to cultural acceptance and how to actually get your developers and your managers and your business units excited about chaos engineering and excited about embracing it. We'll also talk, we'll place a big focus on the culture around chaos engineering. And I'm going to alternate between anecdotes and advice, and when I do, you're going to see a story icon. So it'll just look like this. So this is to help keep things flowing smoothly while I'm alternating between the anecdotes and advice. So let's start off with some known ways for testing for availability. Some very common ways that most organizations know are unit testing, regression testing, and integration testing. There's a history of forcing microservices, the infrastructure, and ecosystem to fail in order to test the entire system. And this is commonly accomplished through these top 3 things. But what most organizations don't seem to have adopted yet is chaos engineering. I've seen this common philosophy where people think that you can accomplish most of your testing through the top 3, and if you're doing it well enough, you don't need the last one. Or people think if you're doing the last one well enough, maybe you don't need the top 3. And I want to share with you a quote from one of my colleagues, Haley Tucker. She says that, and I want to emphasize that both sides of the equation, the unit regression testing side and the chaos side, are required to get you to the level of availability you want. There's differences between both sides. And we're going to get into those a little bit today. So enter chaos engineering. First of all, I want to take a quick survey. Who knows what Chaos Monkey is? OK, so pretty much everyone in the room. Who knows what chaos engineering is? OK, not that many hands. Does anyone want to volunteer to tell me what they think the difference is between the two? And this isn't a trick question. It's just more meant to illustrate a point. Sure.
My understanding is Chaos Monkey is an app that creates chaos. It was built to do that. Chaos engineering is more of a software development mindset and a testing strategy.
Yeah, absolutely. That's a great definition. So for those of you that couldn't hear, he said that chaos engineering is more of a strategy and a discipline, and then Chaos Monkey is more of an app or tool to use with it. And that's a very good definition. But I want to use this to bring up that chaos means a lot of different things to a lot of different organizations, but there are some overarching themes I've found to be consistent when I've been doing chaos engineering in my different organizations. A common definition that I've found really helps, and this comes from the principlesofchaos.org website, it's chaos engineering is the discipline on experimenting on a distributed system in order to build confidence in the system's capability to withstand these failing or turbulent conditions in production. And so that's a lot of words, but essentially it's like making the system stronger through preemptive testing, through experiments. And Chaos Monkey is older news. It's been around for a really long time. It's still actively maintained, and it's open sourced. But the discipline of chaos engineering is emerging. It's fun, it's new, but it really needs to be handled with care and practice. In order to successfully run a chaos initiative in your company, it's very important to understand the fundamental business goals of your products and have a high-level view of what the technology looks like that runs your business. So some reasons for getting into chaos engineering. maybe your business isn't sold on it yet. So here's one reason. You can't keep blaming your cloud provider. I notice a lot of blame is placed on third-party services that maybe you don't have control over. But at some point, it gets to a point where you actually have to own your own outages, right? You can't keep blaming other people. So this is an actual screenshot. It says, "We are having trouble communicating with the Amazon services. Please sign in again to continue," right? You're going to have fallbacks at some point, and chaos engineering can help with that. Here's another reason. Why is there a fear of chaos when it's inevitable? Frank Underwood says it best. He says, "I often found that bleeding hearts have an ironic fear of their own blood." If failure is happening anyway, then why not embrace it? Why is there a fear of doing chaos when systems are bound to be chaotic anyway? And my most insightful slide, computers are complicated and they will break, right? Things get especially complicated when you're running on the cloud, when you have a microservices architecture, and things tend to get a little out of control, and it's impossible for a human to keep up with everything that's going on, Hardware and firmware failures are common regardless of whether you're in a startup or a large organization. And I'm going to place a bet that scaling your services rapidly is a requirement, and chaos engineering is actually a way to ensure more availability while you're scaling. Outages and failures are inevitable. We all know that as engineers, but we can lessen the blow through regular chaos experiments. So now we're going to get into our choose your own adventure. Now that we've defined chaos engineering and we know why we need to do it, I'm going to introduce you to Chaos Carol. So Chaos Carol is going to be our main protagonist today, and she's going to get into a few different situations, and we're going to have to decide what the proper outcome is. She means well, right? But sometimes, she faces hard decisions, and she's not really sure what kind of situation she's going to get into. But her primary goal is to help the company and to help fortify availability. So let's start off with, where is Carol starting her chaos? Because this makes a huge difference. Are you starting it at a startup, or are you at a large-scale organization? And there's a number of questions that come into play. Like, do you have a steady state with your startup? Do you have a normal defined? Are you having outages every single day? If you are, you may need to approach your chaos a little bit differently. If you're in a large organization, how long have you been around? Is there any concept of chaos? Is it going to be met with a lot of pain from upper management? How do you go about convincing upper management that you should do this? So I'm going to begin with the startup, because that's how I began too, and I'm going to share some of my stories from this. So in a startup, I like to call phase 1, introducing the chaos. My first project when I was at jet.com was actually a chaos engineering project. I was about 2 weeks in when there was an outage that brought the site down for an entire day over a weekend period. And it was something that my manager at the time thought could have been caught with chaos engineering. And so he emailed me and he said, "Let's get started on this. We really think we could have caught this." And so, I was 2 weeks in. I was very new at the company. So I said, "OK, what does the system look like now?" I had to get that info. And when you're working in a startup, documentation is few and far between, right? And if you do have documentation on what the system looks like, it's probably outdated. You probably don't have proper tracing yet. You probably don't have a great idea of what's talking to each other, especially at a company that's spinning up new services all the time. And Jet had about 900 microservices. And that was pretty much what I knew about the system. So does anyone here play PC games by any chance? Yeah? Does anyone play Total War Warhammer? Anybody? Yay, hands. So this screenshot is from Total War Warhammer. So I was actually making this presentation in the library, and someone was playing this game without headphones on. And ironically enough, there's this guy, I think he's the Chaos Commander, and he comes on the screen and he says, "The armies of chaos are coming, prepare your defenses." And then he'll change up his messaging a little bit, but really he's just letting you know that he has these chaos armies and they're coming for you. And he's letting you know this every 30 seconds. And when someone's playing that in the library without headphones on, it's pretty annoying. But it got to the point where I started laughing because I was literally creating a presentation on chaos engineering. And I thought, this is so relevant to what I'm doing, right? You have to get to a point where you have to decide, should I let people know I'm doing chaos? Like, is something truly chaotic if I'm letting them know I'm doing it? Or should I just let the chaos run and see what happens, right? That's a question you kind of have to ask yourself when you're introducing these. And so we'll get back into this a little bit later. So like I mentioned before, it's important to start with a steady state. Define your normal system and business behavior for your services. I didn't have that at the time, so I couldn't totally define a steady state. And also determine what the system architecture looks like on a high level. So since there wasn't a diagram of what the architecture looked like, I had to take it a little bit at a time. So like I said, it was a microservices-based architecture. Everyone seems to be moving from monoliths to microservices, thinking it's the silver bullet that will solve all their problems and ultimately save them money, right? There's always money in the microservices or the banana stand. But what people don't immediately realize is that this actually adds complexity in different ways as well. You get to a point where the number of services is in a 1-to-1 ratio with service owners to services, and inevitably things are just chaotic on their own. Let's go back to Chaos Carol. Given this information, how should we start our chaos? Should we randomly turn things off, or should we try to recreate issues that have already happened? So who thinks we should randomly turn things off? Okay, cool. And who thinks we should recreate things that have already happened? Okay, so it's roughly half and half. So actually, what we're going to start with is graceful restarts and degradation. So recreating things that have already happened is great when you're at a certain point, but since there wasn't a steady state, it's not great to start with that because you have no idea what else you could be introducing to things that are already failing. So if you're at a steady state, that's great, and if you have a high-level view of your system defined, that's great. But if you don't have those things, I would recommend starting with graceful restarts and degradation. Start out small. And so back to letting people know. Here's Chaos Carol again. Like, should she let the chaos run on her own, or should she let people know? So who thinks letting the chaos run on its own? Okay, and who thinks letting people know is more important? Okay, so the letting people know won out, and that is very important, and I will stress why that's important later. But in a startup, especially in a place that's not used to chaos engineering, and things might be more chaotic already than normal systems already are because it's a startup, it's very, very important to at least keep people in the know. So that brings me back to this guy. He let people know a little bit too much every 30 seconds. I don't think that's necessary. So how do we define our normal conditions for chaos? How do we define that we're ready? Since there was very little information about this, the results were actually very telling. So how do you illustrate something that's just a theory or a concept, right? Like when we started chaos engineering at jet.com, it was just a theory. We had no idea if it would work, but it was an idea, like maybe we should have more preemptive testing and experiments. So I met with different teams, and I asked them, are you guys ready to start chaos? Like, do you know what this means? And I tried sending out emails, and like I was at a point in the company where I hadn't been working there for that long, so I didn't know the proper form of communication. Jet wasn't heavy users of email, but I was sending out emails like trying to let people know about this, but they were more heavy Slack users. So it's very important to have a communication plan in place, but I wasn't getting a lot of responses on whether I should start this chaos or not, so I assumed it was okay. So I got to the point where I said, all right, should I send it? Should I press send? And I decided to, and the results were telling. So while working on chaos testing is a quick way to meet your new colleagues, it's not a great way. So I met all the people that I did not know that week very quickly. And while engineers didn't exactly welcome this at first, and in addition to their on-call rotations, they eventually adapted. But how, right? So this brings me to my next point of socialization, which is so important with chaos engineering and doing internal tooling efforts. Like socialization is a big piece. it actually tends to be harder than implementation, and that came as a big surprise to me. As an engineer, you're working on this code and you're coming up with this awesome solution, and then the social piece of it comes in. Like, how do you actually get people to adopt it and build a culture around it? Dissemination of information was actually something that needed to go through a lot of trial and error, and I suspect it does at a lot of companies. People, and especially software engineers, like to be in the know, and chaos actually disputes both those points. So as chaos engineers and as people that are developing internal tooling, a lot of your job is not just development, but the socialization and understanding the customer and their needs. At Jet and at many companies I've heard from, there's no mandate in place to force someone to adopt a tool, right? So you have to convince them that, hey, this is a good tool to use. Hey, this will actually help the systems and the business succeed better. So it was important for me to be able to empathetically explain why it was in people's best interest to be chaos. Part of this was relating chaos to automated tests, to SLAs, and ultimately to the customer experience. So culture and chaos. Just when we were starting to get some cultural acceptance around chaos, or so I thought, someone came up to me and actually asked me to turn off chaos during a big deployment. And I sort of facepalmed a little bit because I was like, no, I thought we were doing so well, And two things are important to understand there. One, they probably shouldn't have had to ask me, right? They shouldn't have had to ask to turn it off. They should have been able to on their own. And two, as the chaos engineer, I probably wasn't evangelizing this correctly. This person was seeing chaos as a blocker and a hindrance to their deployment process rather than an essential part of it. And that's what I needed to evangelize better. That's what I needed to help them understand. That chaos doesn't cause problems, it actually reveals them. So how do you form this culture around chaos engineering, a culture where failure is embraced because it is inevitable? So like I mentioned, it doesn't cause problems, it reveals them. So let's go back to Chaos Carol. I mentioned before that there's an opt-in model versus an opt-out model, right? Like if you list all your services and you ask teams, what can be chaos, what cannot be chaos from this, you may have, stronger results than doing an opt-out model. But this is a cultural question too, right? So if chaos has been around for a little while and people are familiar with it and accepting of it, you may be able to go to an opt-out model at some point, but at first it should really be opt-in. People should kind of have control, like, they should be able to prepare their services, especially if it's new. So how do you sell to your customers when they also happen to be your coworkers? As chaos engineers and internal tools engineers, we also have to be good salespeople, whether we like it or not. And what does it mean to be a good salesperson? It means having a good product and knowing your customers. So this brings me to some internal tool selling 101 that I've sort of learned along the way. Focus more on asking the questions rather than answering them. This is especially important at first because it's not all about the information you carry. It's about understanding the worries and thoughts about the manner and adjusting your tooling and execution appropriately. And find customers that are willing to try it first. Most of the time, chaos engineering is just a theory when you're starting out with it. And there's going to be people that are resistant to that, right? But after you develop this tool, it's so easy to want to ask everyone to do it at once and to try to get everyone to adopt it at once. But that's not the right strategy because there's going to be people that push back on it. But there are also going to be people that find it very cool. Find those teams that find it very cool and work with them. Work with them like very closely, get their experiences, and use those experiences to get other teams to adopt it too. And be honest, again, chaos is just a theory when you're first starting out, so don't make false promises about what it can do. And if all else fails with adoption, just cry Wololo. Are there any Age of Empire fans here? Okay, cool. So I'm just going to keep making video game references. Wololo is actually the battle cry that's used in this game in order to convert enemies over to like your side or your way of thinking. So they would use this character, and he would actually say this, and all the enemies would convert to his way of thinking. So, if all else fails with chaos adoption, you can just say that. I'm sure it'll work. So let's go to monitoring. Monitoring is really, really important with chaos engineering too. Useful graphical displays or dashboards that are easily understood by any developer in the company that actively reflect the health of the services and alert on key metrics that are effective and actionable. They're very important. A chaos tool that we use at Netflix called CHAP focuses on what we call minimizing blast radius, which means focusing on our key business metric, and if there's too much impact detected, actually shutting down the experiment early, shorting it early. So we make sure that we're watching our key business metric, and if the experiment and control cluster get too far away from each other, then we shut down the experiment automatically. So with monitoring, it's important to leverage the tools you have. Don't try to remake monitoring tools. Work with what the developers are comfortable with. You want to introduce the least amount of new things to them as possible when you're trying to get them to adopt chaos testing. So at Jet.com, we were heavy users of Splunk. So I leveraged that to monitor the chaos testing at Jet because people were already checking it. At Netflix, we use an internal tool called Atlas, which is actually also open sourced. And we do our chaos monitoring through that. But if you don't monitor and measure the chaos, how can you improve? And how do you actually know it's working? And then also look at your incidents or JIRA tickets recently. Have they been improving from when you started the chaos versus maybe a few months before, a few weeks before? At Netflix, a colleague of mine, Lauren Hochstein, is actually working to empirically track our JIRA tickets and do analysis on whether or not they could have been caught if chaos testing was in place for those services. If you don't have the means to do that yet, I strongly recommend at least looking at your incident reports or your PagerDuty alerts and trying to piece together whether or not it could have been caught with chaos testing. Also, monitoring is not just systemic or technically related. You have to monitor the culture around chaos too. Has the idea of it improved? Are you tracking adoption rates, successes? Those are very, very important things to monitor as well. And most importantly, don't lose sight of your company's customers. Remember that the most important customer is your actual business. Don't lose sight of why you're doing the chaos experiments. Different companies may be doing it for different reasons. And you should keep a watchful eye on your most important business metric. For example, at Netflix, a key business metric might be not being able to stream a video. What could go wrong if you're not able to stream a video successfully? Or at an e-commerce company like a Jet.com, a key business metric might be not being able to add to cart. So, or at a security company like I previously worked at, a key metric might be not being able to arm your system. So those have all very different extreme results to them, right? And you need to strongly consider your customer impact when approaching your chaos testing and focus on what your business goals are and maybe what the worst thing that can happen is. You don't want to cause too much customer pain, and you want to be able to measure that customer pain appropriately. So let's go back to Chaos Carol. So she also has to decide whether or not to start in QA or production. If you're doing this at a startup, or if you're just bringing this to any company in general, I would totally recommend starting in QA. I know it doesn't monitor production appropriately most of the time. If it does, let me know who you are. I want to hear more about that. But I think it's very important to start in QA to at least establish a baseline, to at least get a sense of what's going on when you're running these chaos experiments, and then maybe move to production later. So this brings me to phase 2. Can we cause a cascading failure? So other than socialization efforts at Jet that we obviously needed to go through, chaos testing was going pretty well, and we started to get excited. I thought, if we know at a high level what is talking to each other at this point, can we maybe predict when a cascading failure is going to happen? So cascading failures are when a small fault in one component triggers a fault in another component, which in turn triggers further faults. Cascading failures often lie dormant for a long time until they are triggered by an unusual set of circumstances. The bugs that cause these kinds of software fault often lie dormant, and in these circumstances, it's revealed that the software is making some kind of assumption about its environment, and while that assumption is usually true, it eventually stops being true for some reason. So what we did at JET was we got a bunch of downstream services together, and we had an idea of what cascading failure we were going to cause. And we all sat in a war room because it was something that we had never done before, and even though it was QA, we wanted to prep like it was for production as well. So we did, in fact, cause a cascading failure, but we didn't cause the one that we anticipated. No surprise there if you work in ops, right? So all of a sudden, search wasn't resulting in data anymore, and pricing started seeing timeouts, and then search wasn't handling the pricing timeouts. And then we realized that Elasticsearch was completely down in QA. So we actually ended up causing QA to go down for an entire week because of this experiment. Yep, so that caused a lot of problems, obviously. And though chaos engineering was being accepted well before that, after this, it didn't have a great reputation, right? It caused a lot of problems in regards to fixing tech debt in QA and pushing back on features. I knew I needed to start evangelizing this a little bit smarter. I needed my customers to understand that, no, I didn't bring QA down for the entire week. The tool did, and it probably would have happened on its own anyway, and it might have happened in production. These unusual circumstances could have revealed themselves at any point. And the chaos is actually helping us build confidence in that these faults will be handled correctly when they do occur naturally. So let's go to phase 3, building a failure injection library. So at Netflix, we use this tool called FIT, Failure Injection Testing. It was built by Colton Andres originally, who now works at Gremlin Inc. So we could take this chaos in a different form, like actually injecting it on a code level, actually injecting these failures. So I'm going to take you through some code I wrote. And it's purely to demonstrate that anybody can start small with this and anyone can start adding this to their company. I'm not going to go through all of it, but if you're interested in looking at more of it later, I have my GitHub up here too, and I'll send that out later as well. So let's start with our main chaos function. So this whole library supports the ability to inject a delay or error. There's a simple API for the library, and there are tests with demonstrated use. I chose to write this in F# to show that you could kind of write this in any language. I also love F#, and I think it's very expressive when doing presentations as well. So the chaos module that I'm showing on the screen here defines our main chaos injection. We have name as one parameter, so this is the name of the type of chaos that we're injecting. This parameter is very helpful for logging purposes. If we want to remain truly random and chaotic in our approach and not have the user pick which type of chaos they're doing, it's important to at least have logging in place to allow them to know afterwards, hey, this was this particular type of chaos. So let's go to the next parameter, should chaos. So this is a simple Boolean as a parameter that tells our function whether or not our predefined criteria has been met. And I'll get into the predefined criteria a little bit more later. So it's just a flag, true or false, like, are we allowed to chaos right now? And if it's true, it'll go ahead. If it's false, it kind of serves as a safety mechanism. And then chaos, our final chaos function. So in F#, you can actually include functions as parameters in other functions. So this includes the chaos function that we're injecting into our normal function. And then a little F# specific stuff. The async arrow function created here actually serves as a function which produces an asynchronous computation as an output. And the use of the bang here is interesting. While in most languages it means not, in F# it actually serves a unique purpose of asynchronous workflows. So it allows us to execute our chaos parameter function and enable execution or computations on other threads as well as the chaos is being performed. So let's talk about our types of chaos failures. We have two common failures in any system, as I'm sure you guys can agree to. And one of them is failing with exception. Systems fail because a random exception occurred that we didn't handle correctly. Or, something got latent, sending messages between each other. There was some sort of latency introduced. So I think those are the two most common failures that we see in systems. And those are the types that we're going to be injecting here. It's very simple, purely illustrative. So this is our actual criteria that we're defining that I'm relating to the should chaos that I showed earlier. So this specific criteria is used to illustrate randomness with failure injection and provide an example for how criteria can be defined in the library. So this specific criteria will not inject a failure unless the millisecond at the given time is 0. So something that you could do here is maybe you only want your chaos to run between 9 and 5 when developers are actually in the office and not cause more cell phones to go off, more PagerDuty alerts. So you could actually define your criteria as only run between 9 and 5. There are a few other things that you could do as well. So after defining what went into the library, the API listed reads pretty simply. So A serves as your healthy or normal function, and it gets piped, and that's the pipe symbol there, or injected with the chaos functions listed, given that the function meets the minimum requirements to be injected. So let's go to phase 4, which is our chaos automation platform, or CHAP. So this was something that was developed at Netflix, and it's something that we're actively developing and getting people to adopt now. It was designed to overcome the problems that FIT had, the failure injection testing that we went over earlier. It's focused on minimizing blast radius, looking at those key business metrics and making sure that we're not causing too much pain to the customer. It concentrates on failures to dedicated incidents, and it isolates the statistics of the experimental group and concentrates failures onto these dedicated instances. It also takes FIT and then adds more orchestration, segmentation, automation, and safety to it. So here's an example of how it works. It essentially routes a certain percentage of traffic and splits that traffic in half. It routes some of it to an experiment cluster and some of it to a control cluster. In the experiment cluster is actually where we fail or add latency. And so we can watch the experiment and control cluster and see how out of whack they're getting with each other. If they get too far away from each other, we will short the experiment automatically. So we deploy new clusters. We use custom routing for people in the FIT experiment as well as a similarly sized population. On the experiment cluster, 100% of requests to personalization here are impacted. So you saturate your thread pools, trip your circuit breakers, et cetera. And we call this a concentrate experiment, contrasted to diffuse the experiments that FIT does. So let's go back to Chaos Carol again. When we're rolling out this new tool, we want our customers or the internal service teams to be able to roll out their new changes with chaos enabled, right? We don't want them to run these one-off experiments, right? Our goal here is to actually have chaos run all the time, right? Not just on deployments, not just once a week, not just when you're sitting with the chaos engineers, but actually having it run all the time. So that's a big goal we've had at Netflix right now, to get all the tier 1 and critical services to be running CHAP all the time. And we actually got all of them to include it on their deployment pipelines recently. So that was a big step, but we want to go further. So let's go to phase 5, targeted chaos. So going back to my experiences at jet.com, again, chaos engineering was going pretty well. So we wanted to focus on targeted chaos. Like I mentioned earlier, we have a lot of problems that we tend to blame on our third-party services. Jet was just starting to do geo-replication, and we were strongly relying on Kafka to do that. So we were strongly relying on Kafka to do this, and we were having a lot of problems with it. So we all sat down together and we said, should we start chaos testing Kafka? Should we just target it and see if we can chaos test it to help with our geo-replication efforts? So let's start off with defining some of the problems we were having with Kafka. We were having a lot of problems with monitoring. There wasn't good enough monitoring at the time. And being a startup, we didn't have a full-fledged time series database yet. and it was really hard to monitor what was going on with Kafka without one. We had a few key metrics that were broker specific. Also, with these geo-replication efforts, dealing with offsets was incredibly hard. We were relying completely on Kafka for geo-replication, and the offsets were getting out of whack. And we weren't sure what was causing the offsets to be incorrect. We're also relying on a few key topics that so many consumers were listening to. And like I mentioned, Jet had almost 900 microservices. So you just had random services being spun up all the time that were listening to these same key topics, which led to a huge load on the system, very high consumer read levels. So we started coming up with some targeted Kafka ideas, right? We hadn't done a specific targeted chaos before. What could we do? What kind of chaos could we cause? We could cause complete topic deletion, partial topic deletion. We could force kill services. We could start feeding these bad offsets like we were seeing in practice. We could place some high load on the topics. We could place tens of consumers on the most popular topics and see what would happen there. So we decided to start very small, as we had decided with our chaos experiments earlier. We did a partial topic deletion, and we started adding a little bit of load on random topics. So shots were fired, right? This brings me to a point that it's very important to have a good steady state defined with targeted chaos before you begin. We did not at this point. Like I mentioned, Kafka was causing a lot of problems already, and then we added more problems to the mix. So it was hard to differentiate between what was chaos and what was actually happening already. So we had to wait again until Kafka got to a normal state and then start introducing the targeted chaos again. It's also very, very important when doing chaos to record your success stories. This is especially important during adoption phases. And when you're getting to different levels of adoption and different levels of chaos, you're just going to want to record your success stories with every level. At Netflix, the chaos team is actively introducing a new tool, like I mentioned, called CHAP, which means convincing microservices teams to adopt an unknown all over again. We're in regular communication with these teams over issues they might have with the tool and ways the tool has helped them in ways that we might not be able to empirically record right away. So we started recording testimonials. This customer says, we ran a chaos experiment which verifies that our fallback path works, which is critical for our availability. And it successfully caught an issue in the fallback path, and it was resolved before it resulted in an availability incident. And the exclamation point was actually included in this message to us. They were excited. They were so pumped to let us know that they were part of this journey with us, and they were helping this tool succeed and helping Netflix become more available. Here's another customer testimonial. While we were failing calls, we discovered an increase in license requests for the experiment cluster, even though fallbacks were successful, which was crazy. This part wouldn't have been revealed unless they were running a chaos experiment. And this likely means that whoever was consuming the fallback was retrying the call, causing a retry storm, and causing an increase in these license requests. So this brings me to my next point of engagement guides. When you're getting people to adopt and you're trying to culturally introduce chaos, don't just come in right away and start trying to get people to do things. Come up with an engagement guide. Part of this engagement guide means knowing your company's culture, knowing what works well and what doesn't. Can you and your company's culture force people to adopt a tool? Or do you actually have to convince them to use that? Write that down. Write down what your strategy is going to be. What information do they need to know to succeed and understand? You should also define what constitutes as fully adopted. What does it mean for a team to be successfully running chaos? Does it mean lessening the calls at 2 in the morning? Does it mean being careful before releases? Does it mean being able to track dollars saved, improving customer happiness? Decide what your goal with chaos testing is and measure that and record that. And also decide, should you develop experiments for these service teams themselves or let them do it on their own? So with CHAP, this was something that we had to think about a lot at first. It was a new tool, and we obviously built it so that customers could do this on their own. But we do have to introduce it to them. It's not scalable to sit with them on every experiment and decide how to get them to run, but we need to make the tool We need to have the tool be done well enough to be able to explain to them how to make these experiments and how to know what to test for. So it's important for them to eventually be able to do it on their own. But at first, when you're introducing them to the tool, maybe showing them some examples would be very helpful. So if I can leave you with any takeaways from this talk, it's that pervasive cultural patterns really play out in advocating for chaos. There's going to be adventure choices that you need to make along the way when choosing your chaos, and I just strongly urge you to think about these decisions before you make them, because there could be real customer impact here. And definitely measure your metrics for business and cultural success. Make sure that you're actually improving, and then if you're not, pivot your tools appropriately. That's it. Thank you.